Okay, let's continue. Let's do the next lesson. That's multiplying exponents. And so the main idea is that when you have x to the a times x to the b, once again, you have the same base. If you don't have the same base, you can't do this. In a more advanced class, I'd be asking you to convert it into a different base. But for in today's lesson, the bases are the same, but you may have different exponents. These exponents can be positive numbers, they could be negative numbers, they could be zero, they could be fractions, and the rule is always the same, x to the a plus b. So let's do some examples. 2 to the third times 2 to the fifth. You say, okay, Mr. Adler, the bases are the same. I can add the exponents. 2 to the eighth. How about 2 to the fifth times 2 to the negative third? So you say, okay, Mr. Adler, the bases are the same. 5 plus negative 3 is 2. How about this? How about 3 times 3 to the sixth? Well, the bases are the same. I only see a 6. Maybe the answer is 3 to the 6, but I know that's not true. Please remember, in the world of exponents, there's always a secret. If a number isn't there, there's a secret exponent. It's 1. So 3 to the 7th. Okay, now we said we can use negative numbers. So how about 8 to the negative 2 times 8 to the negative 7? Say, okay, same base. Negative 2 minus 7 is negative 9. Right, and then we could also use fractions, right? How about 4 to the 1/5 times 4 to the 2/3? Well, for those of you who are using calculators, you can put this in the calculator. For those of you, who think you might, how to do fractions, the answer is 4 to the 1/5 plus 2/3. How do we do that? Remember, you cross, and so we get, the answer is 4 times what? 13 over 15. Well, once again, we were just adding the numbers. It doesn't matter if they're positive, negative, or fractions. The next thing we're going to see on the sheet is multiplying like any two monomials. So for example, if I give you 2x to the 5th times 3x to the 7th, how do we take care of this? Very easy. You combine like terms. So my 2 goes with my 3. My x to the 5th goes with my x to the 7th. 2 times 3 is 6. 5 plus 7 is 12. Final answer, 6x to the 12th. It's all the same rules. It doesn't matter if there's positives, negatives, zeros, fractions. It's all the same. Have around 6x to the negative third times negative 5x to the second. Same idea. 6 times negative 5, negative 30. X to the negative third times x squared. Well, negative 3 plus 2 is negative 1. How do I rewrite this? Because textbooks don't like negative exponents. Well, we know from the last class, it's negative 30 over x. And then one more. How about we do one more? How about negative 3x times 5x to the third times, how about 2 2/5 x to the negative 5. Well, you look at this and you say, okay, well, all the bases are the same, right? So I know I'm going to add these together. And the question is, what am I adding together? Well, it's x. Well, there's 1 plus 3 minus 5. And my numbers are the numbers, right? So it's negative 3 times 5 times 2 over 5. if you have a calculator, put it in the calculator, or, by hand, you go, oh, that 5 goes out with the 5. Final answer, -6x to the -1. Oh, we have -1 again. We can rewrite this as -6 over x. And that's it. So some of the problems you'll be getting are, some basic problems like this. There's some application problems which ask for the area. Please remember the area of a triangle is 1/2 base times height, and the area of any quadrilateral is base times height. Can you see everything? Yeah, you can see everything. That's it. And then I gave you some challenge problems also. The answers are all in the homework. Good luck.